good morning, everyone. The movie actually started with the JavaScript for Babies book, but I somehow clipped that out. That's a book I gave to my son, who is turning 2 tomorrow. He can't start soon enough with technology, but I don't think it had the effect I wanted, because every time he sees my laptop, he says 2, which is Dutch for close it, close it. But enough about me. So you already know my name. Interesting pronunciation. I'm going to dive straight in. Anyone who knows these people? Yeah, I see some hands going up. This is the Belgian football club. And I did a project for the Belgian Football Association. So actually these guys are not involved because none of them actually work for a Belgian football club. But the project was for the Belgian First Division in Belgium, of course. And it's called the Pro League. And if you want to participate in the Pro League, you have to score a lot of goals, of course, but you also have to do some paperwork, because there's some regulation that has to be followed. For instance, every club needs to draft a paper where they define, well, our club is owned by these entities or these people, and if you own more than one club in the first division, you need to choose, or you need to sell your club, because you only are allowed to have one club, because it needs to be a healthy competition. But they also need to make sure that everyone gets paid what is owed. If you agree with your player, well, you'll get a salary X. Well, then at the end of the season, we have to make sure that they indeed received all of that salary. They also need to do other stuff like, well, that my stadium is okay. Here I have a report from the fire department saying that the exits are okay. They need to know how many stewards there are, etc., etc. So that's a lot of paperwork that needs to be checked. And it's a handful of people that do that at the Pro League, and they receive these papers because up until last year it was a process still centered around Word templates and Excel sheets, and they sent them to the club, and the club would reply with them, or they would print them and send them back. The people at the Pro League would review them and say, well, here you're saying you have certificate X, but in this document you don't specify the document anymore, or here you say you pay a player this salary, and when we review the salary papers, those things don't match. So they send all the documents back to the clubs. They start to correct them, or come up with the reason why it's incorrect. Fast forward, one football club produces around 10,000 papers for a license to play in the first division. But there's not one football club, there are 16 of them. And in 10 days, the Pro League needs to tell the club, well, we think you can get a license or you can't get a license. So that's a lot of paperwork they need to check. It still is a small team that manages this, but they thought, well, we call ourselves the Pro League, so we need to professionalize on every level. So we also want some software to help us create these licenses and manage these licenses, and that's where me and my team came in. We're not going to look into detail on how the specific application works. We're just going to look at some aspects that we used. We're going to see how we secure the application, how we can make sure that Club X can't get access to the information of Club B, and we're going to see how we automated all of this. Of course, everything which I present here today was based on the project and the needs that we had to cover, and to stay in the same team as yesterday. If you have a hammer, everything you see is a nail. Some of these things will not be applicable to your situation, but maybe some others can help you. So let's first start at the secure part, and maybe this is a bit boring, but I thought this Azure service, which I'm going to present, because everything of the application runs on Azure, had to be addressed, because the feature doesn't get a lot of attraction, I find, and that's Azure Active Directory. We needed a user store, and if you have an Azure subscription, you automatically have an Azure Active Directory for free. So it's a great place to store your users. How can you integrate with it? Well, if you have the .NET application, you can add this NuGet package, and you're all set. Even though you don't actually need this one, it contains some handy configuration methods which you can add to your application. The MVC package comes out of the box with the OpenID Connect package, and that's actually all you need to get started with Azure AD. I know this is centered on .NET, but Azure AD speaks OAuth. So if you have a Java or a Node application, that they can be integrated with Azure AD just as well. So after adding the NuGet package, I can add the I get this extension method which I add to my application, and then I bind to some configuration which I can specify. Here I configure the OpenID Connect options. I specify I want to use a v2 endpoint. Azure AD has two endpoints, a v1 and a v2, with different functionality. And I want to make sure that the tokens which I get from the Azure AD are really of my own Azure AD. So I check here that they need to be validated. The configuration, pretty straightforward. I need to specify where it's located. I need to specify what is the callback path, because if you sign in with Azure AD, you need to be forwarded to the application. This is the default one that's specified by OpenID Connect, but you can change that. And then I need the tenant ID and the client ID. And to get that information, we need to go to the Azure portal. Here you can see the Azure AD for my own subscription, which is called NA for some reason. And the directory ID is actually the tenant ID, which I need in my code. So there are some discrepancies in terminology between the packages configuration and how they're actually called in Azure AD land. So that was pretty straightforward. Then we need to register up our application. Our application needs to be known with Azure Active Directory. And for that, we go to the App Registrations tab, and then we can press New Application Registration, fill in a name, specify if we are a web application or a native application, and then again, the callback path has to be specified. And then we're all done. Here we have a list of all the app registrations in my Azure AD, and then these blank lines have the application ID, and that I just need to add to my configuration file, and we're all set. Now, users in my application, in my Azure AD, can sign in, and I know who they are. If you don't want to do all that in your application, there's a feature in an Azure App Service, which is a website where you can configure authentication authorization, and then it's handled. It's like a proxy. You do a request. This checks if the user is signed in or not. If not, it will handle everything for you and then forward the request to your application. But we didn't use that. So by default, every application which you register in your AD is accessible by all users in your AD, which is something which you might want, but we didn't want that because every football club gets an app registration. We don't want football club A to know how much a trainer makes with the other football club. So we wanted to restrict that. There's a way to do this, and that's called enterprise applications. I don't know why the distinction exists, because if you make an app registration, you also get an enterprise application. And here you see the My App app registration also shows up in here, and if I click through it, I will get this option over here, user assignment required, which I can toggle, which means that if anyone wants to get access to this application, have to explicitly give him access to this application, which can be managed by the users and groups tabs over there. So I don't know why there is a difference between the app registration and the enterprise application, but maybe we have to ask Redmond for that. Managing users explicitly in the Azure AD is certainly something you can do, but it's most of the time easier if you work with groups. You can create a group on the Azure AD level, which means that the group can be managed for many applications, but applications themselves can also promote the usage of application roles. An application can define, well, I know of these roles because that's functionality I will expose to the outside world. Like if you have an on-premise AD and you synchronize it with online, you might have a sales department group which you want to give access to certain applications, and you would manage it on the Azure AD level, but you can manage it on the application level as well. If you have to integrate a lot of applications, you don't want them to pollute all of the groups in your Azure AD. Groups is something which you can get for free in Azure AD. You can just use it. If you want to use the application roles, you need to upgrade your Azure AD. So the groups are just accessible on the AD level, but the application roles are accessible on the app registration page. If you can see I'm in the app registration page and I clicked on a certain application, then I get this button manifest, and if I click that, I get this JSON file, which specifies, well, this application knows that about a tenant 2 users group and about a tenant 1 users group. So if you are feeling confident, you can edit this file and get additional roles in your Azure AD. If you then want to assign people to these roles, you don't have to go to the enterprise applications again. Here you can see I'm in the enterprise application configuration tab, users and group, and here you can see I have 2 accounts with the same name, and Benny Michielsen is assigned to the tenant 2 users group and the tenant 1 users group, and the other Benny Michielsen is assigned to the tenant admins role. We'll see how this works later in the demos. So Azure AD is something which you get for free in Azure, and you can get away with a lot of things. I mean, you can get, you don't have to pay for many things, but if you want to get some more fancy features like multi-factor authentication, which is something which we had to support, well, it's just a tick of a checkbox, and you can get that with your Azure AD, but that's something you have to pay for. But I don't think it's that expensive. It's like 6 or 7 euros per user. If the user exists in your AD, if they exist from another AD, then you don't even have to pay for them, which is the case for us. So our AD costs a couple of 10 or 20 euros each month, and all of the other users actually exist in ADs which the football clubs have themselves. So we now have a way to secure access to our application, but we also have some configuration which needs to be secure, and for that we're using Azure Key Vault. Here you can see a typical configuration file. I blanked out some information. There's this storage part, which is a blob storage connection string, which means if you have that connection string, you can just access all of the files that are stored in it. And then here we have a SQL connection string, and of course, if you have that connection string, you can just get access to all of the data. And then this file just lives somewhere on the file system. Who checked in a connection string? Am I really the only one who has ever checked in a connection string? Okay, most of you are lying. That cannot be the case. So we want to handle these connection strings more securely, because that's really sensitive information, and we can use Key Vault for that, which is again an Azure service which you can spin up. And then here you can see a screenshot of a Key Vault with a secret. So here you can see the connection string has been moved into this service. You can add keys to it. You can add certificates in it. It allows things which you read in textbooks, like rotating keys. You can easily configure here, where you just have to manage the key in one place, and every application that needs that information can collect. I just want the latest customer app database, and they'll get the latest connection string from it. So it's very easy to configure and to maintain. But how do you get access to this Key Vault? Well, again, you add a NuGet package for Key Vault, and then here I add a client ID, which you already saw, which is the ID of my application. And then here I need to specify a client secret. Every app registration can also have app secrets and client secrets, and it's basically a username and a password for your application. So not only do your users have identities, your applications can also have identity. So you can automate jobs, for instance. You can perhaps an application needs to call another application and push some information, but you can give access rights to an application, not necessarily a user account. So that's great. This is where you manage them. So that's great. We got rid of our connection strings, but then we now added this client secret to our configuration page, which is still an open door. Because if you have the client ID and the client secret, you can still get access to Key Vault, so you can still get access to the connection strings. So that didn't solve a lot actually. But nowadays there's a new service which you can use, which is called Managed Identity, which is basically an app registration, but it's handled by the Azure platform. So to turn that on, you just have to go to your application service here. Then there's identity part here, where you can just flick that on, and you use a system assigned identity, which means that the Azure platform will register an application with your ID, and you can now just it's handled without you having to manage anything. You can also do a user-assigned identity, so you can create your own identity and use it across multiple services if that's what you want, but I wouldn't recommend that. After assigning or using the app managed identity, here I am again in Key Vault, and then I'm adding a role over here. So I clicked role assignments, and then if I look up in the list of identities, my application registration, my managed identities appear here. And here you can see the app registration. So it's the same concept, but it's managed by the platform, so you don't have to. And then we can get rid of the client secrets, and then we're all happy. We now have a secured configuration and access to our application. So we now need to look at how we can isolate tenants. We can get a secure access, but how can we work with isolations? Well, the easiest deployment method you have is that you just build an application for one tenant, and if you have need a second tenant, well, deploy everything again. It's the best isolation level because everyone has their own storage account and their own database. It's also the most expensive one because you need to pay for every service twice. If you have 2 tenants, thrice, if that's a thing, 3 times, 4 times as many tenants as you need to spin up every service. You also need to automate or think about how you are going to do your deployments, because you're not just deploying to an app service. No, you need to deploy to multiple app services if you want to deploy your new feature. Or if you make a database change, you need to make sure that the database change is transmit will be applied to every environment. So that's the hard part about this solution. Another way to architect it is to let's create a single app service. So where we can manage authentication and authorization, but we will split the data for each tenant. So let's create a different SQL server and a different storage account for each tenant. And if you would ask me, Benny, I need to create a multi-tenant application, what is my default answer, then this would be my default answer. It's easy to manage because there's only like one deployment which I have to do. And I still get separation of all of the data. But then I still have to think about how do I get a database change to production. If cost is a concern, then perhaps we have to bunch up a bunch of tenants. Here I have a bunch of SQL servers. We can think of it as a single database, and we'll add a column to the data with customer ID or tenant ID. And then we need to make sure that every query which we fire to the database, that it still has this identifier. So that's the drawback of it. Same for the storage account. Perhaps we don't add a bunch of storage accounts for each tenant. We just have one storage account, and we'll perhaps create a folder with the tenant ID and then store all of the files in that folder, and other tenants will get another folder. And that works up until a certain degree, but if you have thousands of customers, then this will probably get troublesome because you can only scale up so much. So perhaps you need to add some sharding to it. We'll add a bunch of tenants on one SQL server and on one storage account, and a bunch of tenants to another one, etc. You can also do something like this, where you integrate it with your pricing structure. So we'll bunch up all of the ones who don't want to pay to the free tier, so they also get a degraded performance. But the people who want to pay for our software, well, they get their dedicated model, their dedicated SQL and their dedicated storage account. Just ways you need to think about it. What we went for is actually this model, because that's what ProLeague asked for us. They wanted the data and the processing of it to be separate for each football club. They are very paranoid about their data being accessible by other football clubs. You might recognize some names. This is also the most expensive solution, but I'll talk about how much we're paying at the end. I'm lying a bit because that's not entirely our architecture. We actually went for this model, where we're deploying an app service for each football club, and they each get their own storage account for file storage and table storage. But they also have their own SQL databases, but it's part of an elastic pool. An elastic pool allows you to pay once, but you can share the performance. So let's say if we gave them dedicated resources, so let's say with stupid amounts. 5 euros for this database, 5 euros for that database, and 5 euros for that database means I'm paying 15 euros, but each tenant would only get performance for 5 euros. But maybe these tenants are not using the application at the moment, then I'm wasting 10 euros because this is the only one that's busy. Maybe they're adding Excel sheets, importing Excel sheets in our database. So they actually need more performance. So if you use an elastic pool, that means that those 10 euros which you're spending here but not really using, they will be automatically assigned to that tenant's database. So it will get a better performance for the same money you're spending. Applying this does have impact on your deployment methods, but again, I'll show you that in the code, which we're going to look into now. So we're going to look at two situations. First, this one is where I want to do a single deployment of my code to Azure, and I want to have separate storage accounts for everyone. So I go to here I am in my Azure application. I have here my homepage. I am Michielsen@hotmail.com here. That means that I'm the tenant admin you saw in the screenshots earlier. And there's already one tenant called tenant1. If I want to provision a new tenant, because that's something that the Pro League, the people in the department that manages the license do themselves. They create their own. They create the applications for each cup, and it's all handled automatically. Not something where we have to come in. So I say, let's say tenant 5, and I want a certain user to get access. And then hit save, and then something is going on. Because what's happening over here? I also added Azure Automation, which is this resource you can see. Azure Automation is basically PowerShell hosted in Azure, and there's one queue job here at the moment. So let's take a look at it. If I can find it, it's a runbook. I can take a look at it. I'll zoom a bit. So this is a runbook, which again, it's just a PowerShell script hosted on Azure, and you can expose these scripts as webhooks. So what my application did, I entered a name and an email address, and then the application calls this webhook. Then the first part of it is just extracting the data. Then I connect to the Azure environment as a service principal. So again, that's an app registration, and this service principal, the app registration, has access rights to my Azure environment and can manipulate it. What happens then is that this part, it gets a template of my environment. I'm using ARM templates here, and ARM templates are descriptions of environments that you want to provision on the Azure platform without you having to go into the portal and clicking, oh yeah, I want a new website and I want a SQL server and I want a storage account. You can do that, of course, but if you have to provision it for on demand or many times, you want to have a description of the environment and then just tell the Azure environment, yeah, please deploy this for me. I will take a look at the template in a bit. After here I'm calling the deployment, and I'm passing a bunch of parameters which are defined in the template. And then I connect to my Azure AD over here. I send an invitation to the user. So if the user account would not exist, it will get an invitation email, and then, oh yeah, please provide us with your credentials, and it can get access to it. I'll also show you that manifest file earlier, where you had to manipulate the JSON. You can do this a bit more in your comfort zone, and that's by using PowerShell. So here I am creating an application role, and I'm assigning the newly invited user to the group. It gets an ID, I enable it, and I add the new role to the application manifests, and we're done with it. So if I go back, I hope by now that the job has finished. Yeah, it's completed. So if I go back to my resource group, zoom out a bit. So there are a bunch of this. You have to believe me. This is the new storage account, and this is the and this is the new database that normally have the same name. Now, can I be sure of it? Well, I also add tags to the environment. Here you see that I added a tag tenant 5 to every resource. So if you have tens or thousands of resources all allocated together, you can create this. If I click this, I'll get all of the resources which have been defined for tenant number 5. So I can quickly access it if I need some troubleshooting. So what was the heart of this? Of course, it's the ARM template, which I have over here. So an ARM template has a few bits. It has parameters, which of course are parameters which you can add to the script. You can define a type and a default value for it. Then you have variables where you can construct names, for instance. I had these cryptic names because I can't have the same names of a resource in the same resource group. So here I can use some ARM functions like concatenate a prefix which I add bm, and then a unique string is generated based on the tenant name. Every time I run this template, these functions produce the same result. So if I would edit function, let's say we need another resource for this for the same tenant. If I then just deploy it with the same parameters which I supplied, then it will just apply the new functionality to the same tenant. So that's a way to make sure you don't have to do this bookkeeping yourself. And then here there's the resource section, which is an array of things I want to add. So I want to add a database for the tenant, which is the one you saw. And then here's the storage account name. I also want this information, the connection strings, to be pushed to Key Vault. I don't want to manage this myself, and updating Key Vault can be done in the ARM template as well. Here I have the Key Vault secret, which I want to add. I need to add them with a name my application will understand. So it will look for connection strings, DB, and then the tenant name. And then I get the value for it. Again, it's a concatenated string of the connection string of my new deployed database. Did I write this by hand? Yes and no. There's tooling in Visual Studio Code which can help you, and in Visual Studio, but it's not really kept up to date. So if you really want to start from scratch, the easiest thing to do is to go into the Azure to do it in the portal. So let's say I want this resource group, and just create me an ARM template for it. That can be done by clicking on automation somewhere. Export template. If I click on it and then wait a few moments, then the entire JSON output will be presented here together with variables and stuff I need to apply. So I can take this ARM template and edit the things I need from it and use that from then on to deploy the application. So what has happened as well is the manipulation of the Azure AD. So for that I go to Azure Active Directory. Then we have the app registrations. And then I need to figure out which one was it. This one, I think. So the manifest file now also has the tenant 5 users group, again by using PowerShell in this case. And then the user is assigned to the group, and for that we also somehow need to go to the enterprise applications, and then again the multi-tenant app with users and groups, and then we would see it not yet been added here, tenant 5 users. So also the user which already exists, I didn't get an email, now can access this application through Azure. How can you use the information in code? Well, let's just exit presentation mode for a bit. I have this my tenant controller is protected with this authorized attribute, which means that every user that needs to access to this functionality needs to adhere to this authorization policy. and the same for the tenant functionality. Here, if I go to the tenant, this was already the tenant. So the tenant user policy needs to be followed, and the management controller specifies that you need to be in this policy. If I can take a look at the code in my startup, it's just from top to bottom to make sure it's easier to follow. So my application says, well, if anyone wants to access this, they need to be authenticated. So that's my default policy. And then I add 2 additional policies. If you want to create tenants, you need to have this policy. In tenants themselves, they have to be part of the or they need to satisfy the policy tenant user policy, because I need to find the correct connection string for the tenant. My application connects with Key Vault and will get all of the connection strings, but I need to select the correct one. And for that, I just use some MVC magic. Where I look into the tenant name is part of the URL, and I extract that information. And then I can just check if the roles which are present on the principal, if that matches, then I'm sure that the user is in that role of that application. If you don't use .NET, well, I already mentioned that Azure AD does OAuth, so you get them as claims in the token, which you can get from the AD server. So that's one example. The ARM templates are really the beast of this solution. They allow you to automate most of this. And every Azure service has a REST API, and then if you're lucky, they build an SDK for the language you want. ARM templates can be executed with Azure CLI or with PowerShell or through Azure DevOps, which we'll see in a bit, or with Azure Automation, as we saw. Same counts for the Azure AD. Azure AD has a REST API. They have a SDK for it. I don't know if it's for Java or so, but at least there is one in .NET. And most Azure services, you can explore them in the Azure portal, where you can, what does this feature do? And then you can get access to some documentation. Azure AD really is another beast. Only a subset of what it can do is exposed on the Azure portal, and most of it is exposed through PowerShell, and some of it is exposed on the SDKs. So when we were busy building this, we actually had to use the REST API because some of it was just not exposed. And figuring out the REST API is not always that happy. So let's now look at the real architecture which we deployed, which is then this one. And it's a combination of the same concepts, but it gets a little bit more interesting because we now also have to deploy multiple application services and update them. And we were used to using Azure DevOps. And if you follow the online tutorials, they're really straightforward. You go in the Azure portal, you click an application service, you're done. You then go to Azure DevOps. You say, I want to deploy this artifact to the Azure service, and well, it's Microsoft, so you can just get UI and you click it all together. But if we wanted a dynamic environment, I was not going to go into the Azure portal and define every football club and then go back into Azure DevOps and link it all up. Because the football clubs do change from time to time in the first division, and we use this mechanism also to deploy test environments, because if they want to experiment with how the clubs will fill in an application, they want to provision new environments on demand. So we needed a very dynamic solution where we could just use Azure DevOps. So I'm gonna start. I didn't create a UI for that part, for provisioning. I think it's this one. Yeah, so I'm just going to spin up this application, and basically what it does, it will call the REST API of Azure DevOps. Azure DevOps, like every Azure service, has a REST API and also a SDK. But I wanted to use .NET Core, and the SDK isn't exposed on .NET Core yet. So I thought on an afternoon, well, why not just use the REST API? So it started something. If I go to my pipelines section and then I go to my releases section, you'll see here that a new release has started for a tenant number 2, which is the name I hard-coded. And this tenant has just been created. So what does what did my application do? Well, it connected to Azure AD. It added a stage, which is called a stage to a release definition, and it started the release of the latest deploy or the latest build to that environment. So next time, if I add a new feature, I can just, if I wanted, I could go to this release definition and create a new release with the latest artifacts, and then I could deploy to tenant 1 and tenant 2 automatically. You see here that it's busy. What does it do? Well, I have a task group over here of a couple of steps, not too much, which says deploy ARM template, which is again an ARM template as you've already seen. It outputs the web application name, which I capture in this step, and then with that application name, I know where I can deploy my code to, which is this step, which is very straightforward with a variable over here somewhere. Here, web app name. This web app name is the output from my ARM template. So ARM templates can also expose data to the outside world. Grouping this together in a task group allows me to easily automate this, and I can just create a new stage, say, well, this stage has to use that template task group, and I only have to manage it over here. If I would need an additional release step, there's only one place where I need to configure it, and then all of the clubs would get it automatically. Well, the ARM template is a bit more interesting because we wanted to use the SQL Elastic database pools, and a SQL Elastic database pool is bound to one resource group, and we wanted different resource groups for the tenants. So the storage account and the web application are stored in a resource group, but we wanted to use the Elastic database pools. And up until a year ago, you couldn't deploy an ARM template to multiple resource groups, but you can do that today. So we have actually 2 ARM templates, if I can find them. So this is the provision database template. Again, parameters, variables to create a unique name, and then I deploy a database to the resource group, and I output the connection string. So this is one deployment, and then I create another ARM template. Another ARM template, and this is the one that Azure DevOps calls directly. And here I have inside this ARM template, I say, well, you also need to deploy the other template. And so here there's a link to the, in this case, it's stored on a blob store. It will execute that and wait for the output, and then I can use the connection string to update the key vault in the key vault for the football club. So we have clear separation of all of the data and the secrets. Something which I did not already mention is that sometimes the deployment of one resource can only happen if another one has completed. That you can see over here. Like the storage account can only be deployed if the or at least the role assignment over here can only be executed if the storage account has been deployed and if the website is deployed, because we have, again, a managed identity. There's a lot more in this ARM template, so if you're interested, just come to me after the session and I'll guide you through it. That's not what I wanted to do. So in the end, this is the current architecture of the application, where we have an administration application, and then every club gets its own information. There's an app registration application where if a club comes in for the first time, they need to do some registration, some bookkeeping. And then I mentioned those 10,000 pages in the beginning of my presentation. Well, this serverless Azure function solution does that, because they still want at the end those 10,000 pages to be printed, I presume. There's some Power BI in there, so every club can get some fancy graphs in their application, and we use application insights to monitor for errors and have some logging. That's it. Thank you for listening.